Okay, I believe we're going to be able to finally finish this section on 10.2. We're doing, again, part B, which is just focusing in on arithmetic series. And what is a series? It's really an arithmetic series is a list, an arithmetic list that we're going to end up adding, finding the sum of all those numbers on that list. We're going to add up all the numbers. Let's go back and review the most important part of yesterday's video, that there's a formula that will allow us to find the summation of however many numbers we have in our list, in our series, right? So if you have like 17 numbers, you're going to have the summation of those 17 numbers will be equal to the number 17. In parentheses, you're going to have your first number, a sub 1, your last number, a sub n, which in this case would be a sub 17, if it were a 17, divided by 2. So you'd add these numbers, divide by 2, multiply by the number of numbers on your list, and that'll give you the summation of that whole entire list. I think we got that down yesterday. Let's jump to today's important key concept, which is sigma notation. All right, let's understand the definition of sigma notation. It says the sum of a series, that's what when we add up all the numbers, can be written in shorthand by using sigma notation. Ladies and gentlemen, this is sigma notation. It's that weird looking E, right? So you're going to have a weird looking, it's a Greek letter E, and it's a sigma, which means you're going to be adding up the list of numbers that you have. And this number down here tells you where to begin. So we're going to begin by a sub 1, plugging in 1 into the function. This is kind of like your a sub nth rule. This is the number that you're beginning with, plugging in 1 and getting out an answer, plugging in 2, getting out an answer, plugging in 3, getting out an answer, till you get to however many numbers they want you to get to. So it's like from 1 to 5 or 1 to 15. I know that might not make too much sense right now, but hopefully it does in a moment. Let's look at these notes from the book. The first value of k is 1. In this case, it says k equals 1. So you're going to input a 1 and get out your first actual answer. So right here, we have a problem. It says the summation from 1 to 12. Now, what does that mean? That you're going to plug 1 into your formula. It's kind of like your a sub nth rule, but instead of n, they're using k. I don't know why they're using k. For me, it would make more sense if they had n equals 1 and had an n right here. So you'd have a sub n equals 4 times n plus 2. Anyways, they're using the variable k instead of n. Let's go with it. So they want you to plug in the number 1. So 4 times 1 is 4 plus 2 is 6, right? They show the work right here. 4 times 1 is 4 plus 2 is 6. So that's your first number, okay? Then from 1 to 12, remember, so you got to go for the number 2 now. Plug in 2. 4 times 2 is 8. 8 plus 2 is 10. That's how you get that second number, 10. Then you plug in 3 into here, and then you plug in 4 into here, plug in 5 into here, plug in 6 into here, all the way till you get to plugging in 12 right into here, and you'd get your 12th term. So if you do plug in 12, 4 times 12 is 48, plus 2 is 50. So we need to understand that this sigma notation is really producing a series. And what is the series? It's just a sequence that you're adding up, and it's an arithmetic one, right? A sub 1 is 6, a sub 2 is 10, a sub 3 is 14, all the way till you get to a sub n, which in this case is a sub 12. How do I know that? Because it tells you from 1, by plugging in 1, that's a sub 1, all the way to 12, okay, which gives you 50 when we plug in 12. Now, we still need to add up all these numbers. So instead of going, okay, 6 plus 10 is 16, plus 14, that's 20, that's 30. 30 plus the common difference is 4, so 30 plus 18, and then 18 plus, and you keep adding. Instead of doing all that, we're going to use the summation formula that we already know, right, from yesterday's video. Here's a summation formula. So let's use that summation formula to figure out the answer to this guy. So you're going to have S sub n, and we already know that there's actually 12 instead of the n. So we're going to say the summation of those 12 numbers will be the number 12 times your first number, which we said our first number was 6, plus the last number, which we said was 50, divided by 2. So 6 plus 50 is 56 divided by 2, and we need to multiply it by 12. So the easiest way to approach this, I would say, is to do 12 divided by 2 and get 6, and 56 times 6 on a calculator is 336. So the summation of those 12 numbers, this whole thing equals 336. Okay, it's that easy, but it does get a little bit more challenging. Let's actually go to our notebook here and let's jot down this exact problem. So I wrote down the problem here. I also brought my summation formula with me because, again, the sigma notation implies that you're going to create a list and you're going to add up all your numbers. So instead of adding up all those numbers the long way, since there's 12 numbers on this list, instead of doing that, let's actually just find the first number, a sub 1, the last number, a sub n, which is technically going to be a sub 12 because we're going from 1 to 12. Okay, and of course there's going to be 12 numbers, and you could solve using that. So you don't want to make the entire list. You just want to find the a sub 1, the a sub n, and also recognize how many numbers are on the list. So how many numbers are on this list? If I find out my a sub 1, well, what's my a sub 1 going to be? It's actually plugging in 1 into this formula. 4 times 1 is 4, and 4 plus 2 is 6. Okay, now how about my a sub 2? We don't need to do it, but let's just do it for funsies here. Plug in 2 right in here. 4 times 2 is 8, and 8 plus 2 is 10. Okay, now we're already seeing that there's a common difference here. So if the first number is 6, the next number is 10, the common difference is 10 take away 6, which is 4. Okay, so the common difference is 4. Now if you wanted to, you could technically, logically make the list, right? You could say 6, 10, 14, 18, 22, and you could go all the way to 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Get a huge list, and then because the sigma notation tells you to add them all up, you could get a calculator and go 6 plus 10 plus 14 plus 18 plus 22. That would take a really long time. It's better to just identify your a sub 1, which is 6. That's going to go right here in the formula. Identify your a sub n, which will be a sub 12. So that's really going to be, let's write that out, 4 times 12 plus 2, that's going to be 50. So a sub 12 is 50. So far we have the a sub 1, which we needed right here. We have the a sub 12, which we needed right here. And we also know that there's 12 numbers on the list. So a sub 1, a sub 2, a sub 3, all the way till you get to a sub 12. So let's write down the formula. The summation of these 12 numbers on this list that we don't even see in front of us will be 12 times your first number, 6, plus 50 divided by 2. I know I'm explaining the whole thing over again, but hopefully you get a better understanding of this now. And again, you could say 12 divided by 2 is 6, and then just multiply 56 times 6, giving you your final answer that we got before, which was 336. So of course it gets a little bit more challenging, but before we do that, let's actually do another one that's a little easier than that one. Let's say we see that sigma notation, and it says k from 1 to, I don't know, let's say 5, and let's say that the function itself is a 2k. How about that, 2k? All right, so let's think about this. What would be your a sub 1 term? What number would be the first number on your list? Well, you would plug in 1. You'd have 2 times 1. That would be 2. That's your first number on the list. What's your second number, third number, fourth number, fifth number? But then again, let's not find a2, a sub 2, a sub 3, a sub 4, a sub 5. Let's just find a sub 5 because that's where that's the last number on the list. So let's find a sub 5. How do we do that? By plugging in 5 into here. 2 times 5 is 10. Okay. So we have a sub 1, we have a sub n, which is technically a sub 5, which means we can now use the summation formula. S sub 5 equals, how many numbers are on the list? 5, times a sub 1, the first number on the list, plus the last number on the list divided by 2. Do the math. 2 plus 10 is 12. 12 divided by 2 is 6. 6 plus 5, or 6 times 5 is 30. So S sub 5 is 30. That makes total sense because if I did plug in a 2 right here, it would give me a 4. So a sub 2 is 4. If I plugged in a 3 right here, it'd give me a 6. So a sub 3 is 6, and a sub 4 would be 2 times 4, which would be 8. And if you did add 2 plus 4, it's 6, plus 6 is 12, plus 8 is 20, plus 10 is 30. If you added them all up, it would give you the summation of 30. Okay, so you don't want to do this because that takes too long. You do want to understand that this is saying that you're going to add up all your numbers, find your a sub 1 term by simply plugging it in, find your a sub n term, your last term, your a sub n term, find it by plugging in that last input right in there. That'll be your a sub n term. And of course, the n will be how many numbers there are in your list. And you know, if you start at 1 and stop at 5, there's going to be 5 numbers on your list. It gets a little bit more complicated when you don't start at 1. Let me show you. So here we are on this example number 6 in the book. It says to find the summation from 4 instead of 1, the sigma notation, from the summation from 4 to 18, where your formula is 6k minus 1. Okay, so this gets a little confusing. If you read the book on how they tell you to do this, it says you need to find the sum of the series. So find a sub 1, find a sub n, and find n. Now, it says there are 18 minus 4 plus 1 or 15 terms. Now, a lot of people are going to freak out right here. What do they mean by 18 minus 4 plus 1? You see, it doesn't start at 1. If it was k equals 1, if it was k equals 1 to 18, yeah, there'd be 18 numbers on your list. But it's 4, from 4 to 18. Okay, so let's think about that. The book says 18 take away 4 plus 1. So there's really 15 numbers on your list. Now that might confuse you, so let's think about this. If this were a 1, what would we have? Well, you'd have, when you plug in 1, you'd get your a sub 1 term. When you plug in 2, you'd get your a sub 2 term. When you plug in 3, you'd get your a sub 3 term. When you plug in 4, you'd get your a sub 4 term. When you plug in 5, you get your a sub 5 term. And of course, you would keep going till you get to your a sub 18th term, which would be a total of 18 terms on your list, right? Yes. So they don't start at 1. They start at 4. So that's why I put this in red. They start right here at 4. So it's really not 18 take away 4 to find out the number n that's in your list, how many numbers are in your list. It's actually 18 take away these first 3. So that's where the book gets this 18 take away 4 plus 1. There's a plus 1 because you include that 4th term in your list, right? You start with a sub 4, so that's 1, 2, 3, 4, 5, till you get all the way to that a sub 18, which is no longer 18 terms, but it's actually now 15 terms. Okay, so in other words, this is going to be the first number on your list. Over here, these guys, we're eliminating them, right? They tell you to start at a sub 4. That's technically going to be your first number of your list. Okay, like I said, it gets a little confusing. Let's actually copy this one in our notebooks. So notice that I kept my summation formula here because we're going to have to use it to find these numbers added up. Now, how many numbers are on my list? It's 18 take away 4 plus 1, all right? So if I had a 25 up here, it'd be 25 take away 4 plus 1. So 25 take away 4 would be 21, plus 1 would be 22. If I had an 8 right here, 8 take away 4 plus 1. As a matter of fact, check this out. If we go up to this one that we did earlier, that did have a 1, and I wanted to know how many numbers are on the list. If I go 12 take away 1 plus 1, 12 take away 1 is 11, 11 plus 1 is 12. So yeah, it makes sense that there's 12 numbers on the list. Take this number, subtract this one, then add 1 to it because you're including this number on your list. I hope that makes sense. I mean, it makes sense to me, but then again, I'm the math teacher, huh? Okay, so right here, how many numbers are going to be on the list? It's going to be 18 take away 4 plus 1. That's going to be your n. Your n is going to be 18 take away 4 plus 1. So that's really going to be, your n is 15. So that means that there's, what does this mean? That there's 15 numbers on your list. Okay? So let's find the first number on our list, our a sub 1. But you see, the a sub 1 that we're going to find is not really plugging in 1. It's actually plugging in this first value 4. Okay, so the first number on our list, when I plug it in, it'll be 6 times 4. 6 times 4, that's 24. 24 minus 1, that's 23. So you really have the first number 23. Okay, so if you wanted to, you could plug in, you could find a sub 2, the next number on your list, right? You could plug in 5 to find a sub 2, and then 6 to find a sub 3, and then 7 to find a sub 4, and plug in 18 to find your a sub 15. Does that make sense? I hope so. I know this is kind of, I'm asking if it makes sense. It's like if you could talk to me right now through the computer. That doesn't make sense. All right, so my a sub n, my last number on this list will be plugging in 18 right into here. So when you multiply 18 times 6 is 108, take away 1, you'd get 107. So on this list, that did not start by plugging in 1. It started by plugging in 4. When we plug in 4, that actually gave us our first number on the list. And by plugging in 18, it gave us the last number on the list, right? So now that we have that first number and that last number, and now that we know that there's 15 numbers on the list, not 18, 15, because we didn't start at 1, now we could actually use the summation formula. Let's do that. So we're going to say the summation of the 15 numbers we have. Again, it's not 18, it's 15, because you started at 4, and you're including that as your first number. So it's really 18 take away 4, which is 14, plus 1 because you're including it. That's why there's 15 numbers on the list. So the summation of those 15 numbers on the list will be the number 15 times a sub 1, which we said was 23, plus a sub n, which we said was 107 by plugging in that 18, divided by 2. So let's do the math here. 23 plus 107 is 130. And then divided by 2, that'll give us 65. But don't forget about the 15 out here that's in the front. So we really have 15 times 65, which equals, the answer would be 975. I use the calculator. Hope you do too. 975. So that's the summation of the 15 numbers that's indicated by that summation notation right there. 975. If we go back to the actual example in the book, they tell you that the correct answer is C, which is 975 right there. Same answer we got, okay? So we're going to be doing a total of 4 of these for homework today. We might as well do this one right here, number 6. It's guided practice. Let's do this number 6, and notice again it does not start at 1. So if I asked you how many numbers are on this list, on this summation that they want you to have, it's not 21. If it were a 1 to 21, yeah, it'd be 21 numbers on your list. But how many numbers are actually on this list? To find out how many numbers you actually have on this list, you're going to take the 21, you're going to subtract the bottom number, but then you have to add 1 to it. Why? Because you're actually including the number when you plug in 9, right? Think about it. The first number on your list, here's the spot for the first number. How do you get that first number? By plugging in not the number 1, but by plugging in 9. Okay, so 5 times 9 is 45. 45 plus 6 is 51. So this is 51. Hold on a second. 51 is the first number on the list that's indicated right here in this series, in this summation right here. And the last number, if you keep going all the way to the last number, that would be plugging in 21 into here. 5 times 21 is 105. 105 plus 6 is 111. So the last number right here will be 111. Okay, so we have our a sub 1, we have our a sub n. We even know our n. What's our n going to be? It's going to be 21 take away 9. That's really a 12. Plus 1 is 13. So there's actually 13 numbers on this list, not 21. There's 13 numbers on the list. And now that we know our n, our a sub 1, our first number, our a sub n, our last number, now we could actually use the summation formula, which is n times the first number plus the last number divided by 2. So let's actually work this out. The summation of those 13 numbers will be the number 13 times the first number 51 plus 111. Let me do this, I'm sorry. Let me do this in blue. Divided by 2. So 51 plus 111 is 162. So we really have 13 times 162 divided by 2. And 162 divided by 2 is 81. I just did that on the calculator. So you really have 13 times 81. Final answer will be 1053. And don't think I did that in my head. I have my calculator right here. So the summation of these 13 numbers is 1053. Now we didn't have the list of 13 numbers. They just gave us this summation notation. Again, we found the n by going this one, take away this one, plus 1. That tells you how many numbers are on your list. And then we actually plugged in the beginning value that they want you to plug in, 9. That way you could get the first number on your list. Plug in the final input right here. That way you could get your last number on your list. And now that you have the numbers of numbers on your list, the first number and the last number, you could plug them all into here. The numbers, first number, last number, plug it all in, you get your final answer, summation right there. So I would really like you to do this assignment. We're going to be doing page 671, 57 through 60. Maybe instead of doing that, I should do this. I mean, you guys have to write it down in your notebook, so I wrote it down in my notebooks. 57 should be really easy. Well, all of these should be not that bad. Why? Because you're using the summation formula on all of them. Sigma notation means that you're going to be adding up all of the numbers on your list. Now, of course, you don't have a list here. You could come up with a list if you want to. How would you do that? Plug in 1, that'll give you your first number. Plug in 2, that'll give you your second number. Plug in 3, that'll give you your third number, all the way to plugging in 16. So when it starts with 1, it's clear to see that you're going to have a total of 16 numbers. Again, we need the summation formula. That's what we're going to be using. So there's my summation formula. You want your first number, you want your last number, you want the number of numbers on your list. Okay? So when it's 1, it's easy because there is 16 numbers on our list. If you do that little trick that I ask you to do, 16 take away 1 plus 1, that's just 16. So on number 57, we know that there are a total of 16 numbers on the list that we do not see. On number 57, we could also find a sub 1 by simply plugging in this first value. 4 times 1 is 4. 4 take away 2 is 2. So the first number on our list is 2. And we could also find a sub n, and let me do that in blue as well, by plugging in the last number on our list, which is 16. So 16 times 4 is 64, and 64 minus 2 is 62. Okay, so now that we know the n, which is right here that we need that n, now that we know the a sub 1, the first number on the list, a sub n, the last number on the list, we'll be able to plug it into here and get our final answer. Okay, I'm not going to do that work for you. This is your homework assignment. I hope you could do that yourself. So always identify your n, how many numbers are actually on your list, the first number on your list by plugging in this first number, and the last number on your list, your a sub nth number, by plugging in this last number, the input right there, and figuring out what your last number is. That way you could plug in the n, the a sub 1, and the a sub n into the formula to get your final summation. Let me jump to number 59, and if I show you how to do 59, you guys should be able to do 58. Again, you need to show all these, at least these 3, all right? It says 60, but this is going to be like a bonus question. Number 59, how many numbers are actually on this series right here? We don't see the list. How many numbers are there? Well, it would be 16 take away 5 plus 1. 16 take away 5 is 11. 11 plus 1 is 12. That means that there's 12 numbers on the list. Now, how do we get our first number on the list, a sub 1? How do we get that? By plugging in not 1, even though that's what it means. You're going to plug in the first number by plugging in this first number, k, which is 5 right here. So 2 times 5 is 10. 10 plus 6 is 16. So the first number is actually 16. Now the last number, a sub n, what's the last number going to be? The last number is going to be actually plugging in 16 right here, which is 32, and 32 plus 6 is 38. So the last number on your list is 38. There's a total of 12 numbers. That's very interesting. Anyhow, let's use the summation formula. So we're going to have S sub n, which is really S sub 12, because there's 12 numbers on this list. There's not 16 numbers on the list. There's only 12 numbers on the list. Okay, and then we're going to have the formula, which is the number 12 plus the first number on your list, which we said was 16, plus the last number on your list, which we said was 38. Then you divide that by 2. So we end up with 12 times 54 divided by 2, and 54 divided by 2 is 27. Or you could also do this. You could say 12 divided by 2 is 6, and then multiply 6 times 54, however you want. 6 times 54 is 324. So your answer for number 59 is 324. That's the answer right there for number 59. Okay, so knowing that, you should be able to do 58. Okay, so finish off 57, do 58, copy down 59, and number 60 will be like a challenge question. I want to see if anybody is able to figure this out, because you're not starting at 1, you're starting at 0. Okay, so let's see who could get the correct work here. Don't think of it as mandatory. Let's think of it as a bonus question. Let's see who could get all 4 questions explained and possibly turned in on Friday. All right, but I just want to see who could do number 60. See if you could logically figure that out. So again, sorry about the long video. I hope you guys are doing well. Stay safe.